Hello everyone, still with me here, Firda, in Basic PLS SEM using Smart PLS 3. After we studied in session 3 about the evaluation of measurement model, now we are going to session 4, evaluation of structural model. Structural model, also called the inner model. The structural model also display the relationship between construct. Assessment of the structural model result enables you to determine the model's capability to predict one or more target construct. Structural model assessment procedure consists of 6 procedures. Number 1, collinearity assessment, path coefficients, coefficient of determination or R-square value, the effect size, F-square, applied folding and predictive relevance, Q-square, and effect size small q square. Collinearity arises when two indicators are highly correlated. Collinearity among latent variables are assessed through variance invalid factor or VIF. The threshold value, the VIF, bigger than 5 indicated a potential collinearity problem, and VIF more than 3 indicate a potential collinearity problem according to Diamantopoulos and Sigor 2006. And how to know the VIF value? Go to the Smart PLS report in Excel file that we have saved, and then go to this collinearity statistic, click on that. As you can see that all the number is below 5, so therefore it doesn't have a collinearity problem. Procedure number 2 is path coefficient. Coefficient is the coefficient linking construct in the structural model. It represents the hypothesized relationship of the strength of the relationship. For example, path coefficient close to +1 indicate a strong positive relationship, and vice versa for negative values. The closer the estimated coefficient are to 0, the weaker the relationship. So very low values close to 0 generally are not statistically significant. There are 2 ways to see the path coefficient. First, go to the PLS, and after you calculate the PLS algorithm using this button, and the report will show like this. This is structure model. This is the path coefficient, relationship between construct here. And also the second way is go to the Smart PLS report on the path coefficient and then click on the show. This is the path coefficient. You can see the relationship between construct. The higher number is close to 0, showing the strong of the relationship. Clicking here on the complete chart, open a bar chart which visualizes the path coefficient for each model relationship. As you can see here, the higher the bar, the stronger the relationship. Here's the result of path coefficient. You can see directly from the PLS software and from the PLS report on the bar chart tab. Whether a coefficient is significant depends on its standard error that is obtained by bootstrapping to enable computing the empirical t-values, p-values for all structural path coefficients. The t-values, when an empirical t-value is larger than the critical value, we conclude that the coefficient is statistically significant at a certain error probability. Commonly used critical values for two-tailed tests are 1.65 with significant level 10% and 1.96 with significant level 5%. To know the t-values, you have to go to the Smart PLS software and create the bootstrapping report. Go to here, calculate, click, then click on the bootstrapping. 500 iteration, basic setting, we use default, subsamples, and then start calculation. You can see the t-values or p-values directly from this report that provided by the software, or you can export it to Excel file. Yes, start exporting. Save in the folder and naming under bootstrapping, so you can differentiate between algorithm and bootstrapping report. Then save it. And it will give you the Smart PLS report on the bootstrapping. This is the Smart PLS report on the bootstrapping report. If you can click here on the path coefficient to see whether it is significant or not, it will just bring you to this report. You can see that the statistic 2.9, 0.887, 2.1, 0.18, and 0.6362. What does that mean? Commonly used critical values for two-tailed tests are 1.65, significant level 10%, and 1.96 for significant level 5%. Now we can compare the relationship between construct, whether it's statistically significant or not, using the t-statistic. So only a relationship between company competency and the customer satisfaction is statistically significant, and between customer satisfaction and customer loyalty. Most researchers also use p-values to assess the significance level. When assuming a significant level of 5%, the p-value must be smaller than 0.05 to conclude that the relationship under consideration is significant at 5%. When assuming a significant level of 1%, the p-value must be smaller than 0.01 to indicate a relationship is significant. Let's see the p-values on the Smart PLS report. Here 0.03, 0.376, and all this, what does that mean? We can see against the critical value. The critical value for significant level of 5% must be lower than 0.05. So this relationship between company competency and customer satisfaction is statistically significant. Also between customer satisfaction and customer loyalty is significant because the p-value is lower than 0.05 at 5% significant. The individual path coefficient can be also interpreted as the standardized beta coefficient in an ordinary least square or OLS regression. A 1 unit of change of exogenous construct changes the endogenous construct by the size of path coefficients when everything else remains construct or ceteris paribus as per Hare 2010. Procedure number 3 to assess the structural model is the coefficient of determination or R-square value. The R-square indicates the variance explained of the endogenous variable by the exogenous variable. The R-square value range from 0 to 1, with higher level indicating higher levels of predicting accuracy. Hare 2011 and Hensler in 2009 articulated that values of the 0.75, 0.5, or 0.25 can be described as substantial, moderate, and weak. Chin in 1998 articulated the value of 0.67, 0.33, and 0.19 as substantial, moderate, and weak, so you can choose between them. The R-square can be obtained from the corporate reputation model on the algorithm report. Just go to under quality criteria, click here, show, and it brings you to the R-square and R-square adjusted. So what does that mean? higher level indicating higher level of predicting accuracy. If we can see that here, the higher is on the customer loyalty, which indicates 0.8, 0.38, which is moderate predicting accuracy. Procedure number 4 is effect size F squared. The assessment of effect size allows the researcher to observe the effect of each exogenous construct on endogenous construct. Cohen in 1998 guideline for assessing 5 F squared are that values of 0.02 represent small, 0.15 is medium, and 0.35 is large effect of the exogenous latent variable. Effect size values of less than 0.02 indicate there is no effect. How to know the F squared values? Go to the Smart PLS report on algorithm and click on the F squared. Because it will bring you to here, to this number, and then compare it against the criteria. These tables show us the number and relationship between construct. It means that customer satisfaction give a large effect on the customer loyalty. The other number is smaller than 0.02. It means doesn't have effect. Procedure number 5 is blindfolding and predictive relevance, or Q square. In addition to evaluating the magnitude of R square values as a criterion of predictive accuracy, researchers should also examine the Stone-Geiser Q square value. And this measure is an indicator of the model's predictive power of predictive relevance. The Q square value is obtained by using blindfolding procedure for a specified omission distance d with the values between 5 and 10. Q square value larger than 0 suggests that the model has predictive relevance for a certain endogenous construct. In contrast, the values of 0 and below indicate a lack of predictive relevance. Now look at our report. We need to go to corporate reputation model on Smart PLS software on the Smart PLS workspace, and then click calculate and blindfolding to create blindfolding report under omission distance 7, and then start the calculation. Here is the report of blindfolding, and here is the report of the blindfolding after it exported to Excel file. Go to construct cross-validated redundancy, and it shows you the values of the Q square. What does that mean? The values are greater than 0 indicate that the model has predictive relevance. Here's only customer satisfaction, customer loyalty has value greater than 0 and indicate the model has predictive relevance. The last procedure to assess the structural model is number 6, the effect size small q square. The effect size q square allows assessing an exogenous construct contribution to an endogenous latent variable's big Q square value. As a relative measure of predictive relevance, small q square values of 0.2, 0.02 indicate exogenous construct has a small predictive relevance, 0.5 indicate exogenous construct has a medium, and 0.35 indicate exogenous construct has a large predictive relevance for a certain endogenous construct. So how to evaluate was one must calculate the little q square using this formulation according to HER 2017, and this is the example. These two values are input for computing the Q square effect size of customer satisfaction and customer loyalty, and the result is 0.115. It's indicating the medium predictive relevance. as we've been through to all 6 procedures.